Hello everyone, I'm Alfian and today we are going to solve the Hackerrank challenge called the insert node at the tail of a linked list. And for this particular challenge we are in the data structure section, and the challenge itself, it says you are given the pointer to the head node of a linked list and an integer to add to the list. Create a new node with the given integer. Insert this node at the tail of the linked list and return the head node of the linked list form after inserting this new node. The given head pointer might be null, meaning that the initial list is empty. And for the function description, it says complete the insert node at tail function with the following parameters: singly linked list node, pointer head, a reference to the head of a list, and the integer data, the data value for the node to insert. As you can see, we are using the Java 7 for this particular challenge. If you want to use something else other than Java 7, then go ahead, I encourage you to do so. And for this particular challenge, we have the static function called the insert node at tail, which is the expected data type of the function, is returning a data type of singly linked list node. And for this parameter, it says like in the function description, we have two parameters of the insert node at tail function. For the first one, which is the singly linked list node itself, called the head, and the next parameter, which is data in a form of integer. So since we are working on nodes, chaining several nodes as one, then we have the sample input and the sample output right here. And without further ado, let's solve this. Since we are returning data type of the singly linked list node, since the parameter has the same data type, then we can pass in the head parameter as the temporary placeholder. And for the next one, we can diagnose what is going on inside the system out print line or the console.log if you are using JavaScript. Then for the system out print line, we can pass in the check is head null using the question mark, and then using the plus sign, and then for the next one, using the parenthesis to check if the head is equals to null, and this will returns either true or false. And for the next one, we can use the system out print line again. Then for the next one, we are passing the data directly. So let's run this to see what it is about. And we have the debug output of the is head null, which is equals to true, and we don't have current node as the head of the singly linked list. And this is the data printed 5 times, just like the expected output right here. And the input of the standard input right here, we have 5 data as the integer elements right here. And we have for the sample test case 1, we only have 3, and this is the expected output. And if you look over the expected output, is just like we are working on an array, like we are trying to print an array. But don't get me wrong, we are using the linked list, which is another data type, a different data type than using the list or the array. And for this challenge, we have the input of 3, then the expected output is also 3, and it's printing 3 times, just like on the function right here, like we are working in a form of for loop. But for this particular challenge, this is the in a form of function, so don't worry, let's solve this together. So for the next one, we can add a check if the head is equals to null. Since we already know that head is already null, then we can assign using the return, assign a new constructor, return new constructor of the singly linked list node that takes one parameter of the data. Why data? It's because the singly linked list node right here, reference, we have only 2 properties. The first one, which is the data itself, and the next one, the next property, which is the another singly linked list node that needs to be chained with the singly linked list node right here, called the next property. And if you open the line number 1 right here of the input java.io.asterisk, we have a singly linked list node class right here, and assigning the data of the singly linked list node. Then we have the public int of the data right here that contains as the property of the singly linked list node. And for the next one, or the second parameter, which is the next, then we can change it using this another singly linked list node that chain, and then in the form of the singly linked list. So let's fold this code and focus on solving this challenge by creating chain it using the head.next. But before that, I forgot to run the code again to see if the if else is working properly using the return new constructor of the nodes. For the sample test case 0, and we have only one output, which is 1 for 1, and this is a good start because it is matched with the first expected output right here. And for the rest of the output, then we can work our way towards the desired goal. And we have the debug output right here, and if you notice something, the first one is equals to true, and the next check is head equals to null, which is false right here. Then we already know that only the first one is printing true, or the first one is not printing, does not contains any head. And for the next onwards, we have head is equals to true and null is equals to false right here. So for the next one, we can change the head.next using the, you might be guessing, using the new singly linked list node again, singly linked list node, and then assigning the data for the next one. Let's try this, and we have only 1 for 1 and 4 7 4. We only printing the first one and the last one instead of the middle part right here. And also the same thing goes to the sample test case 1. We only printing the first one and the last one instead of the full expected output right here. So let's solve this by creating, instead of using the new right here, new nodes constructor, then we can assign the function itself. The function itself is called the insert node at tail. We can call this insert node at tail. Then we are passing the head.next as the first parameter, and for the next parameter is the data itself. Passing the head.next will cause the insert node at tail function calls will be checking if the head is equals to null, which is true for the next iteration of the function call, and then we are returning a new nodes as the data right here using the data that we are passing as the second parameter right here. Then the second parameter will be processed as the first parameter of the new nodes constructor right here. So let's run the code again to see if it works, and there you have it. We have 5 outputs and it's as expected output. And the debug output, we have, since the first one we only have 5 outputs, then since we are using the recursive call, then the output is total, we have 2 outputs at once. Then since we have 30 lines, then 30 divided by 2 equals to 15 outputs. And that is the problem of using the recursive call. If we have 5 outputs right here, the more inputs that we have, since we have 5 inputs, then the recursive calls will have 15 outputs. What happens from the test case 1, we have 3 inputs, then the recursive calls does have 12, which is 2 times of the initial system out print lines, which is only 6 lines, or only 3 output debug output right here. So the problem of using recursive call is, let's say we have 100 inputs, then the recursive call will have the stack overflow issues. What is stack overflow? Stack overflow, we are calling the function right here, and after calling the function right here, of course we are calling this function, and inside this function we are calling another function right here again, and for this function right here we are calling another function, and until the data is empty or there is no more data to be processed, and we ultimately returning the head, and all of the recursive function will be completed. So that is the problem of using the recursive call and causing the stack overflow. And in short, the more data it is, then the longer or more processing time or the memory stack that needs to be printed. Like for example, the system out print line right here, initially we only have 5, and the recursive call of the insert node tail right here we have 15. Then it is of course a problem if we have 100 of data. To get around this, instead by using the head.next, assigning the function itself as the variable, then we can use another one called the, let's move this return of the new constructor, and then we are assigning this as the variable called the singly linked list node called the new node, and then we construct our singly linked list node right here as the new node, and then for the return statement we are passing the new node instead. And for the next one we can assign the singly linked list node again called the current node, and we are passing our head right here, and variable is not used. Then we can use the while loop. While the current node is not equals to null, we can check if the current node is not equals to null, then we can shift the pointer or the current node right here as the pointer, as our pointer right here. We can check, we can shift the current node using the current node dot next. We can check the chain if it's null or not. Then for the assignment we can use the current node is equals to the new node right here. So let's run the code to see if it works, and we only have 141 as the output right here instead of 5 outputs of the expected output right here. And for the next one we only have 1 output right here instead of 3 outputs. I assume that the while loop right here is not working as expected. What about using the current node dot next? We are assigning the new node, and this is, it says the null pointer access, the variable current node can only be null at this location. Don't worry, since we are using the while loop check if the current node is not equals to null, then we can move this to the current node dot next. So let's run this again to see what went wrong. So we have the output right here, exception in thread main, and we have no response on the standard output of the head output right here, that we have errors. So let's delete the current node dot next assignment. So let's use the current node dot next right here, check if the current node dot next of the next chain of the nodes of the singly linked list nodes right here is equals to null. If it is, then we can, if it's not, then we can move or shift the pointer of the current node pointer right here to the next current node. Then we can assign the current node using the new node right here and returning head. And we are not required to move the head as the pointer right here. Let's leave the current node as the pointer, and let's return the head as it is, as the whole chain of the nodes. So let's run this again, and we have the 141 error again, 141 output, and the expected output should have 5 outputs instead of only 1 output. So let's use the current node dot next again, assigning the next, and let's run the code again. And there you have it. You have the proper output, and the debug output is reduced from the 15 and from the 30 I believe is 30 to only 10 lines of debug output right here. or we only have 5 outputs. And for the next one, we only have 3 outputs, just like on the amount of the data. We have 6 lines. So what happens if we use only if instead of while? Let's test this out. And we are only printing the first node, and then the second node, and the third node as the last value of the data right here. And for the sample test case 1, we are passing because it's only printing 3 elements, and sample test case 1 only has 3 elements, so it is no problem with this one. But for the test case 0, it is a problem. So let's go back to the while loop right here. What about using this instead of using the current node next pointer right here? You might be wondering why we are using the current node as the one that iterates and the one that has been assigned as the new node instead of the head, and why is the output affects the head, while on the other hand we are only processing the current node chains using the dot next, and then assigning the new node as the current node dot next right here, and using the while loop right here. All of the processing instead of the head. Why is it affects the head node directly? So let's imagine this if we are using this head directly instead of using the current node. Let's use head directly as the pointer instead of this current node. I was using this Ctrl D to select multiple elements or selecting multiple variable names. It was current nodes, so let's use the head instead. Let's run the code again, and we have a pointer error right here. We only printing the 4th element and the 5th element, or the last element, instead of the whole inputs right here of the 1st, 2nd, and the 3rd element. So what about the test case 1? We are printing only the last 2 elements as the output right here. So that is the difference between using the current node pointer right here versus using the head as the pointer. So let's go back to the current node variable. Let's submit the code since we are already using this. And there you have it. We have succeeded all of the implementation. So let's delete the system out print line. Let's submit this again. And so that's about it. I hope you understand my explanation. If you still don't understand this code, you can ask me in the comment section. I will happily answer it. Or if you have any better solutions regarding this challenge, or a better approach about the singly linked list nodes, or working with singly linked list specifically, tell us what you think in the comment section. I hope you have a great day, and I will see you in the next video. Goodbye.